Hi, good evening. Am I audible to all of you? Okay. You see the white screen? Is it visible to all of you, white screen? Okay, so today we'll be starting winds and pressure belts. Okay, let's start this topic. See, this is a very important topic when we begin to understand the climate conceptually. Okay. This topic is basically a feed to many other topics in climate. Okay. Now, when we begin the topic, we start with winds and pressure. Okay. And then further, when we have understood winds and pressure, we will also analyze pressure belts. Okay. Now, let's understand winds. Okay. For understanding winds, we need to know what is air, and air is nothing but atmosphere around us, which consists of multiple gases, like oxygen, nitrogen, carbon dioxide, carbon monoxide, hydrogen, helium, xenon, neon, right? So the entire atmosphere, so that is air. And when air is in motion, when air is in motion, it is called wind. Okay, air in motion. When air is in motion, it is called wind. Okay. Now we have analyzed earlier, the latitudes, longitudes, tilt of the earth. Earth rotates as well. Okay. Now what we see is that our earth, our earth is basically geoid in shape. Earth is geoid in shape, and there is a tilt. क्या है? Tilt. Okay. Now because of the tilt, different latitudes, let's say 23.5 degree north and 23.5 degree south. So different latitudes receive different sun's energy or sunlight, which is also called sun's insolation. So different latitudes receive different sun's insolation. Sun's insolation will be different at 23.5 degrees, which is, this is Tropic of Cancer. Sun's insolation will be different at Tropic of Capricorn, right? Sun's insolation will be different at Arctic Circle, and sun's insolation will be different at Antarctic Circle, which is 66.5 degrees south, and definitely it will also be different at 90 degree north and 90 degree south. Right? सन्स इंसोलेशन इज डिफरेंट. इसका कारण सिर्फ एक ही है, और वो जो सबसे बड़ा कारण है वो है tilt of the earth on its own axis. Earth is tilted by 23.5 degrees with respect to vertical, and Earth is tilted by 90 minus 23.5 degrees, which is 66.5 degrees with respect to horizontal. Okay. So, since Earth is tilted and it is almost geoid shape, which is similar to spherical shape, different latitudes on the surface of the earth receive different sun's insolation. Okay. अब देखिए होता क्या है कि ये जो हमारा बेल्ट है, लेट्स से दिस बेल्ट हियर, ये कौन सा बेल्ट है? दिस इज 0 degrees. This is 0 degree equator. ये जो बेल्ट है इसमें सबसे ज्यादा सन्स एनर्जी रिसीव होता है बिकॉज इट इज द सेंट्रल लैटिट्यूड. एंड व्हाई द मैक्सिमम सन्स एनर्जी? बिकॉज द सन shuttles, the direct rays of the sun are found between 23.5 degrees north and 23.5 degrees south. ठीक है ना? Direct sun's energy, and because of that, the maximum insolation on the surface of the earth is found on equator. Okay, found on equator. Let us see it a little more closely. So, what we are speaking about here is the 0 degree equator, then in the north we have 23.5 ये है, and this is 23.5 degree south, right? So we have seen the seasons. Remember the seasons, right? In the month of June, the direct rays of the sun are on Tropic of Cancer. Yes. So the direct rays of the sun are found around 23.5 degree north. In the month of December, the sun's rays are on Tropic of Capricorn, which is the southern hemisphere, 23.5 degrees south. And in between June and December, कौन सा महीना है? September. The sun's rays are directly on equator. In the month of September, right? So how is the sun shuttling? The sun is in June around Tropic of Cancer, the direct rays, and then because of revolution of the earth, the sun's direct rays shift to equator in September, right? they shift to equator in September, and further revolution, the sun's rays shift to Tropic of Capricorn. So this time when you see here in the month of June, this is basically summer season for northern hemisphere, and when the sun is directly shining on equator, so for equatorial regions, September becomes the summer, and when the sun's direct rays are directly on Tropic of Capricorn, the month of December becomes the summer season. है कि नहीं? Yes. Now after December, the sun's rays, because of revolution, are again direct on equator, which is that month. We'll add March to our category here. So when the sun's direct rays are back on equator in March, so this is the second time in 1 year that the direct rays of the sun are directly shining on equator. ठीक है? फिर उसके बाद फिर से cycle repeats. The sun's direct rays are again around Tropic of Cancer in June, and so on. But what we have seen is the sun's direct rays in 1 year, they shine for one time. They shine, we can write, once on Tropic of Cancer in June, once on Tropic of Capricorn in December, but they shine twice. The direct rays of the sun are received by equatorial regions twice in a year. कब कब होता है? मार्च में भी होता है, सितंबर में भी होता है. Yes. So since the sun's direct rays are on equatorial regions twice in a year, इसी वजह से हम बोलते हैं कि क्या बोलते हैं? That equatorial regions receive maximum sun's insolation among any other latitudes on the surface of the earth. Yes? Is this point clear to all of you? और इसी को हमने देखा था कि ये जो जोन है आपका, this zone here is also called torrid zone. Equatorial region तो maximum heated, लेकिन जो region between the tropics होता है वो in comparison to any other region in the world is also maximum heated. Torrid zone. Yes. Is this point clear until now? बताइए. Clear to all of you? बना लो डायग्राम को. And since we know the sun's direct rays are twice on equator, this region becomes the region of लो प्रेशर, ये क्या बन जाता है? लो प्रेशर. Now let us understand this low pressure, that there is a linkage between equatorial regions receiving maximum sun's insolation and low pressure. तो जहां पे sun's insolation maximum होगा वहां पे सबसे ज्यादा intense low pressure मिलेगा. Okay, but what is this low pressure? ये low pressure होता क्या है? Now low pressure occurs when the surface of the earth is heated by sun's energy, and because of that the surface becomes higher in temperature. इसका जो temperature है वो increase हो जाता है. And since the surface of the earth becomes higher in temperature, जो air है which is in contact with the surface, the air which is in contact with the surface also gets heated up. So this is a cross medium heating which is possible through conduction. आपने word सुना है conduction? What is conduction? Transfer of heat from one medium to another. यहाँ पे कौन से दो मीडियम है? One is the surface. Surface दो तरीके से हम लिख सकते हैं. Surface could be either land or surface could be water, means a sea or an ocean or a river or a lake. It could be either land or water. तो जब भी land or water which is on the surface is heated, the temperature rises, and this rise in temperature also heats up the air in contact. Also heats air in contact. ठीक है, एयर की हीटिंग हो गई. तो ये जो एयर के पार्टिकल्स होते हैं which are located close to the surface, ये हीट अप होने के बाद एयर पार्टिकल्स become volatile. क्या हो जाते हैं? Air particles become volatile. Means they start moving haphazardly. But whenever air is heated, the molecules start moving haphazardly, but their direction is also, कैसी है direction? Direction is upward. कोई भी चीज जब हीट अप हो रही है, it is like, just imagine the surface of the earth, which is land and water, like a container which contains water and it is being boiled from below. तो जो गैस से हीटिंग हो रही है, consider it the land or the water, और उसके ऊपर क्या है? Air, which is as if the water in the container, जो हम घर में पानी बॉईल करते हैं, तो जो वेपर बनती हैं वो सीधा ऊपर जाती हैं, राइट? They move vertically up. Now, in the case of heating of the land, when land heats by conduction, the air in contact, it also moves up because one is air becomes volatile, another is air expands. And when it expands, it tends to spread in a larger area upwards. ठीक है, देखिए कैसे ये हमारा लैंड है या फिर वाटर सरफेस है, ठीक है. जब ये हीटिंग होगी तो यही एयर मॉलिक्यूल्स will tend to expand, and when they expand they rise up in search of more space, ऊपर बढ़ने लगते हैं। और जब ये एक्सपैंड हो जाता है एंड ये राइज अप करने लगता है तो these air molecules, what they do is air molecules leave the surface, सरफेस छोड़ के ऊपर चले जाते हैं, है कि नहीं? And when these air molecules leave the surface, ये जो हमने एरिया यहां पे हम देख रहे हैं जहां पे हमने लिखा है एयर मॉलिक्यूल, ये एरिया, दिस एरिया becomes a vacuum, क्योंकि एयर मॉलिक्यूल जो सरफेस के टच में था, because of gravity it has left the surface because sun's insolation is maximum, and because of that the air molecules have expanded, and since they have expanded they are in search of more space, they leave the ground surface and that ground surface ultimately becomes a vacuum, एक खाली जगह। और इसी वैक्यूम को हम बोलते हैं, we call this vacuum as low pressure. This vacuum is called as low pressure. Are you getting this point? ये समझ में आया? What is low pressure? Yes? सबको?
Yes, sir.
Very good. ठीक है? So this is low pressure. Then, so what is low pressure? अभी जब जिसकी हम बात कर रहे हैं, that is the equatorial region, ये वाला, है ना? अब देखिए, इसके एकदम ऑपोजिट होता है रीजन जिसको हम बोलते हैं हाई प्रेशर। So what is high pressure? It's exactly opposite of low pressure, meaning whenever the land or water is not heated, what happens is air molecules so this happens when there is absence of the sun, ये कहां पे अधिकतर होता है? हायर लैटिट्यूड्स में। This happens in higher latitudes. So because of absence of the sun, by virtue of gravity, air molecules remain close to the ground. Remain close to the ground. Yes or no? यहाँ पे हीटिंग नहीं हो रही है, लैंड सरफेस है तो लैंड सरफेस की भी हीटिंग नहीं हो रही है, वाटर है तो वाटर सरफेस की भी हीटिंग नहीं हो रही है, इसलिए एयर मॉलिक्यूल्स रिमेन क्लोज टू द ग्राउंड. Nothing to push the air molecules upward because in the absence of heating, the air molecules are not volatile. They do not move upward. They do not leave a vacuum. तो इस केस में the air molecules remain glued to the ground. और इसी कंडीशन को बोला जाता है हाई प्रेशर. तो हाई प्रेशर कब होगा? जब विंटर्स होंगे, और जब समर्स होंगे तो क्या होगा? लो प्रेशर. हाई प्रेशर when the temperature is cold, low pressure when the temperature is high. Yes, Understanding this point? So high pressure means winters, ठीक है? And low pressure means summers. Yes or no? Low pressure during summers and high pressure during winters. ये पॉइंट सबको क्लियर हुआ अभी तक? यस? अच्छा, अब हमने बोला था कि एयर इन मोशन इज कॉल्ड विंड. एयर इन मोशन इज कॉल्ड विंड. तो ये जो विंड है ये कहां से कहां मूव करेगा? लेट्स से दिस इज अ हाई प्रेशर जोन जहां पे एयर मॉलिक्यूल्स आर क्लोज टू द ग्राउंड एंड दिस इज अ लो प्रेशर जोन जहां पे वैक्यूम है. यहां पे क्या है? वैक्यूम, राइट. यहां पे क्या है? The air molecules are close to the ground. So when air molecules are close to the ground, on the surface, the wind will move. The air will move from high pressure to low pressure in the form of wind. तो ये जो wind है, it is basically surfacial and it is moving from high pressure to low pressure. Why it is moving from high pressure to low pressure? The simple reason is to fill the vacuum. किसका vacuum? Low pressure का vacuum. This is a thumb rule that wind always moves from high pressure to low pressure. जहां पे air molecules ज्यादा होंगे वहां से move करेगा towards vacuum where there is absence of air molecules. Is it clear? सबको? क्लियर है ना? अभी प्रेशर वर्ड से अगर आप कंफ्यूज हो रहे हैं तो प्रेशर इज नथिंग बट प्रेशर इज फोर्स अपॉन एरिया. क्या होता है प्रेशर? इज फोर्स अपॉन एरिया. इस केस में हम किसके फोर्स की बात कर रहे हैं? फोर्स ऑफ एयर मॉलिक्यूल्स ऑन द ग्राउंड. ग्राउंड पे हम लोग रहते हैं. So the force of air molecules in an unit area is called pressure. तो जहां पे एयर मॉलिक्यूल्स ज्यादा होंगे वहां पे प्रेशर भी ज्यादा होगा. जहां पे वैक्यूम होगा वहां पे प्रेशर विल बी लेसर. Yes? Yeah. So that's why to fill the vacuum, the air molecules move in the form of wind from high pressure to low pressure. Clear? Yes? Now see, let us come back to our earth. हमने देखा this 0° equatorial region is a region of low pressure. अच्छा, ऊपर क्या हो रहा है यहां पे? ये देखिए यहां पे क्या हो रहा है? This is 90° north. ठीक है ना? This is 90° south. Yes? अब these are the two latitudes on the surface of the earth which are respectively called as North Pole and South Pole. यहाँ पे जो sun's insolation है is minimum. Sun's insolation is minimum because they are the farthest from the center of the earth. तो around equator sun's insolation the highest. तो sun's insolation यहाँ डायरेक्ट जाता है, यहाँ पे slant होके रेज जाती है. यस, तो जहां पे रेज आर डायरेक्ट वहां पे हमको लो प्रेशर मिलता है, जहां पे रेज आर स्लांट वहां पे हमको क्या मिलता है, हाई प्रेशर. तो वी आर टॉकिंग अबाउट हाई प्रेशर एट नॉर्थ पोल and also high pressure at South Pole. 0 degree equator is the region of, it is the region of maximum insolation, and 90 degree north as well as 90 degree south are the regions of minimum sun's insolation. Now these two high pressure zones, these three in fact, two in northern and southern hemisphere respectively and one in the central regions around equator, they are called as, इनको हम बोलते हैं thermally induced, क्या बोलते हैं, thermally induced pressure belts. Thermally induced pressure belts. What is thermally induced? Induced due to temperature. एक जगह टेम्परेचर ज्यादा है, एक जगह टेम्परेचर मिनिमम है, तो टेम्परेचर की वजह से ये प्रेशर बेल्ट बनी है. ओके, क्लियर अंटिल नाउ? Thermally induced pressure. Acha. You see this belt here? The area around Tropic of Capricorn and the area around Tropic of Cancer, right? So this is Tropic of Cancer. Now let us assume that, let us take a benchmark. Let us analyze at 30 degree north latitude and let us analyze at 30 degree south latitude. ठीक है? What do you think? There will be low pressure or high pressure at these two latitudes? हमने 30 डिग्री नॉर्थ एंड 30 डिग्री साउथ लिया है फॉर द पर्पस ऑफ स्टडी, क्योंकि वो लाइन तो हमने बनाई है 23.5 डिग्री नॉर्थ की, लेकिन व्हेन द सन इज इन द नॉर्दर्न हेमिस्फीयर इन जून, जो मैक्सिमम उसका एक्सटेंट होता है वो ट्रॉपिक ऑफ कैंसर के अराउंड है. तो ट्रॉपिक ऑफ कैंसर एक लाइन है, लेकिन जो हीटिंग होती है वो पूरे जोन की होती है. अब इंडिया में आप देखो, जब भी जून में आप जाओ, वेदर यू गो टू हैदराबाद, वेदर यू गो टू चेन्नई, और यू गो टू दिल्ली और भोपाल, अहमदाबाद, जयपुर, लखनऊ, हर जगह गर्मी मिलेगी आपको, राइट? तो हर जगह समर्स होगा, होता है ना? तो इसलिए पूरे जोन की हीटिंग होती है. इसलिए हमने फॉर द पर्पस ऑफ स्टडी वी हैव टेकन 30 डिग्री नॉर्थ एंड 30 डिग्री साउथ. नाउ टेल मी, व्हाट डू यू थिंक, देयर विल बी हाई प्रेशर और लो प्रेशर इन दीज लैटिट्यूड्स? बताओ. Come on, try. Tell me, will there be high pressure or low pressure around 30° north and 30° south latitude? बोलिए. Low pressure. अच्छा, reason? Why low pressure? See, when we talk about 30° north and 30° south, देखो अभी अभी हमने देखा कि ये जो winds हैं वो कहां से कहां मूव करती है, हाई प्रेशर से लो प्रेशर. अब ये जो लो प्रेशर है यहां से तो विंड ऊपर जाएगा नहीं जाएगा ना, लेकिन विंड यहां आएगा जरूर. यस, विंड आएगा क्योंकि ये सबसे ज्यादा इंटेंस लो प्रेशर है. विंड दोनों हेमिस्फेयर से यहां पे जाएगा ना. अब ये विंड आ कहां से रहा है, अब देखिए इसका सोर्स को समझते हैं. एक चीज क्लियर हो गई कि जो हमारा इक्वेटोरियल रीजन है दैट इज द रीजन ऑफ लो प्रेशर एंड बिकॉज ऑफ दैट इट बिकम्स द रीजन ऑफ रिसीविंग विंड्स. यहां पे विंड्स आएगा क्योंकि यहां पे वैक्यूम है, राइट. लेकिन ये जो विंड यहां पे आ रही है, यू मस्ट बी वंडरिंग, is it originating from 30° north and 30° south latitude, or is there some other source? ये विंड आती कहां से? Let us understand that. Now let us see. देखिए, this is 0° latitude, this is 30° north, and let's say this is 30° south. Okay. Now ये जो विंड है स्टार्ट कैसे होता है कि ये जो जोन है वो एक हीटेड जोन है. हीटेड जोन है, राइट. तभी हम इसको बोलते हैं लो प्रेशर. तो हीटेड जोन में होता क्या है कि जो एयर मॉलिक्यूल्स हैं वो हीट अप होके दे स्टार्ट मूविंग अपवर्ड्स. एयर मॉलिक्यूल्स स्टार्ट टू मूव अपवर्ड्स बिकॉज ऑफ हीटिंग. And when air molecules start to move upward, they leave a vacuum on the ground. लेकिन अब ऊपर क्या हो रहा है? As they move up, the temperature of the air molecules, the temperature of the air molecules reduces. Yes or no? नीचे हीटिंग हो रही है, तो when the air molecules are close to the ground, their temperature is high, but when the air molecules leave the surface and start moving vertically upwards, their temperature reduces with increase in height. The reason is that they are no more close to the surface now, and as we move up, height के साथ temperature reduce हो रहा है. अभी जो temperature reduction होता है ये किस रेट से होता है? इसको हम बोलते हैं लैप्स रेट. लैप्स रेट का मतलब है कि टेम्परेचर ऑफ द एयर मॉलिक्यूल्स विल रिड्यूस बाय 6.5 डिग्री सेंटीग्रेड पर किलोमीटर. पर किलोमीटर मतलब वर्टिकल डिस्टेंस, वर्टिकल हाइट. तो विद एवरी 1 किलोमीटर ascendance of air molecules, the temperature will reduce by 6.5 degrees centigrade. Or we can say that temperature reduces by 1 degree centigrade for every 165 meters. कन्वर्ट करके ना, कैसे कन्वर्ट किया? 6.5 डिग्री सेंटीग्रेड is the reduction in 1 kilometer of vertical altitude or vertical height. अगर 1 डिग्री को हम देखना चाहते हैं कि 1 डिग्री रिडक्शन कितने डिस्टेंस पे होगा, तो 1 किलोमीटर विच इज इक्वल टू 1000 मीटर्स कन्वर्ट कर लेते हैं, डिवाइडेड बाय 6.5, तो ये हमारा निकल के आता है 165 meters. That means for every 165 meters movement of air molecules upwards, temperature will reduce by 1 degree. Right? तो अगर हम अज्यूम करते हैं कि सरफेस ऑफ द अर्थ पे टेम्परेचर इज लेट्स से 30 डिग्री सेंटीग्रेड, जहां पे हीटिंग हो रहा है, तो if I say that our air molecules have moved by let's say 9000 meters or 9 kilometer suppose, ठीक है, तो कितना टेम्परेचर हो जाएगा उन एयर मॉलिक्यूल्स का? 9 मल्टीप्लाइड बाय 6.5, यस, इतना टेम्परेचर रिडक्शन होगा ना, तो 6.5 मल्टीप्लाइड बाय 9 will give us means temperature will reduce by 58.5. तो हमको क्या करना पड़ेगा, यहां पे टेम्परेचर निकालने के लिए 58.5 माइनस 30 सरफेस पे था, टेम्परेचर रिडक्शन कितना हो गया 58.5, तो टेम्परेचर अल्टीमेटली हमें कितना मिलेगा, माइनस 18.5 मिलेगा, नहीं मिलेगा, सॉरी, यस, माइनस 18.5. हम रिड्यूस तो कर रहे हैं 30 से, लेकिन सब्ट्रैक्शन कैसे होना चाहिए, 30 माइनस 58.5, क्योंकि 30 सरफेस पे है एंड रिडक्शन इन टेम्परेचर इज बाय 58.5 डिग्री सेंटीग्रेड. 30 माइनस 58.5 विल गिव अस माइनस 18.5, तो काफी ठंडा हो गया ऊपर जाके, राइट? नाउ दिस इज एट एन एल्टीट्यूड ऑफ 9000 meters or 9 kilometers. नाउ है बेटा, एक मिनट, ओ यस यस, सॉरी सर, हाँ 28.5, ठीक है, कितना हो गया? नाउ लेट अस अज्यूम द एयर मॉलिक्यूल्स हैव असेंडेड बाय let us assume the air molecules have ascended by 5000 meters. अगर 5000 meters से ascend होता है which is 5 kilometers, so at the rate of 6.5 multiplied by 5, तो 32.5, सरफेस पे टेम्परेचर इज 30 डिग्री सेंटीग्रेड, तो 30 माइनस व्हाट विल बी द टेम्परेचर हियर, 30 डिग्री सेंटीग्रेड माइनस 32.5 विच इज इक्वल टू माइनस 2.5, राइट? तो यहां पे टेम्परेचर हमें कितना मिलेगा? अब ये जो टेम्परेचर रिडक्शन हो रहा है, एक चीज हमने देख ली है, वेदर इट इज 5000 meters or it is 9000 meters, temperature is below 0 degree centigrade or temperature is sub zero. तो सब जीरो टेम्परेचर पे क्या बनता है, क्या होता है, क्या बनता है? क्लाउड्स बनते हैं, और इसी प्रोसेस को हम क्या बोलते हैं, कंडेंसेशन. दिस प्रोसेस इज कॉल्ड कंडेंसेशन. मींस ये जो हमारे एयर मॉलिक्यूल्स हैं, जब ये मूव करते हैं ऊपर, तो ये कुछ पानी भी लेके जाते हैं अपने साथ, दे कैरी सम वाटर मॉलिक्यूल्स आल्सो. यही वाटर मॉलिक्यूल्स जो लिक्विड फॉर्म में नीचे थे सरफेस पे, दे बिकम वेपराइज्ड और दे कन्वर्ट इनटू गैसियस फॉर्म, है कि नहीं? दे कन्वर्ट इनटू गैसियस फॉर्म एंड देन दे स्टार्ट मूविंग वर्टिकली अपवर्ड्स, एंड व्हेन दे स्टार्ट मूविंग वर्टिकली अपवर्ड्स तो क्या होता है ऊपर जाके? कंडेंसेशन। कंडेंसेशन का मतलब है कि the water molecules which have converted to gaseous state, they convert back to liquid form. उसी को कंडेंसेशन बोलते हैं because of reduction in temperature. तो सरफेस पे क्या हो रहा था? evaporation. Evaporation is conversion of water molecules from liquid to gas. और अपर एटमॉस्फेयर में क्या हो रहा है? वही गैस, the water vapor converts back to liquid. तो conversion of gas to liquid is called condensation. Conversion of liquid state to gaseous state is called evaporation. है कि नहीं? Condensation के लिए what do you require? Reduction in temperature. Evaporation is opposite. We require increase in temperature, then only evaporation will happen. तो नीचे evaporation हुआ और ऊपर क्या हुआ? Condensation. यहां पर evaporation, ऊपर condensation. तो condensation ने क्या बनाया? Clouds. बन गए clouds. अब ये जो एयर मॉलिक्यूल्स ऊपर मूव किया है, ये जो क्लाउड वाला रीजन है, whether it is 5000 meters or 6000 meters or 7000 meters, this region has abundance of air and water molecules. यहाँ पे air भी है, यहाँ पे water molecules भी हैं. इसी के amalgamation को हम बोलते हैं clouds, right? यही region आपका क्या हो जाएगा? This region will become a zone of high pressure. Yes or no? नीचे तो वैक्यूम क्रिएट हो गया, ये जो वैक्यूम है ये क्या है? दिस वैक्यूम इज लो प्रेशर, और जो ऊपर है वर्टिकली अबव, दैट इज हाई प्रेशर. यस, यहां तक क्लियर हुआ? यस सर. ठीक है, अब देखिए नेक्स्ट स्टेप. दिस जोन इज लो प्रेशर एंड बिकॉज ऑफ मूवमेंट ऑफ एयर मॉलिक्यूल्स ऊपर क्या बन गया? हाई प्रेशर. ये कौन सा लैटिट्यूड है? दिस इज 0 डिग्री एंड 30 degree north, this is 30 degree south. Now when the air molecules move upward, they create high pressure. अब देखते हैं यहां पे क्या हो रहा है. Now these regions compared to equatorial belt is less heated. दोनों हेमिस्फेयर्स में ये भी कम हीटेड है और ये भी कम हीटेड है. तो लेस हीटेड होने का मतलब है कि यहां पे जो इवेपोरेशन है, इवेपोरेशन भी ओवरऑल कम ही होगा, होगा कि नहीं? अगर इवेपोरेशन कम है तो जो हमारे एयर मॉलिक्यूल्स हैं they will tend to remain near to the ground, near, okay, not exactly they get stuck to the ground, but they are near to the ground. Why? Because if evaporation is less due to lesser temperature, average annual temperature की हम बात कर रहे हैं, not a temperature in a month, हम पूरे year को average temperature की बात कर रहे हैं, तो air molecules generally tend to remain close to the ground. अगर एयर मॉलिक्यूल्स आपके ग्राउंड पे हैं तो राइट अबव दीज एयर मॉलिक्यूल्स आपको थोड़ा सा वैक्यूम मिलेगा, मिलेगा नहीं मिलेगा? दोनों तरफ above 30 degree north as well as above 30 degree south. अगर एयर मॉलिक्यूल्स नीचे है तो ऊपर वैक्यूम होगा, यहां भी वैक्यूम होगा, एंड above 30 degree south भी वैक्यूम होगा. Yes? Now we have read अभी थोड़ी देर पहले that air always moves from high pressure to low pressure. एयर ऐसे ही मूव करेगा ना, करेगा नहीं करेगा? But what will happen after the air molecules reach this vacuum? ये वाला vacuum and ये वाला vacuum. Now since evaporation is less, due to gravity, the air molecules will also tend to get pulled downwards. Gravity है, evaporation कम है on an annual basis. तो यहां से भी air molecules नीचे जाएगा और यहां से भी air molecules नीचे जाएंगे. तो इसी को हम बोलते हैं air molecules descend or air descends. Getting this point? यहां पर भी air is descending and here also air is descending. Yes or no? क्यों descend करता है? Because of gravity. यहां भी because of gravity. Yes or no? And when air molecules reach the surface, they create a high pressure zone here. What are they creating? A high pressure zone. These molecules are also creating a high pressure zone here. And we again know that air molecules will move from high pressure to low pressure. To fill the vacuum which is here, इस वैक्यूम को भरने के लिए भी जाएगा ना. तो वही एयर जो आपकी हीटेड होके which was moving vertically up, that the same air gets distributed between two hemispheres from the upper atmosphere. तो अपर एटमॉस्फेयर के हाई प्रेशर से दोनों जोन में लो लो प्रेशर की तरफ जाएगा और जब वो लो प्रेशर की तरफ आएगा दोनों लैटिट्यूड्स में, तब वो एयर मॉलिक्यूल क्या करेगा? इट विल डिसेंड डाउन. और वही एयर मॉलिक्यूल्स व्हेन दे डिसेंड डाउन, these air molecules in the form of wind, they start moving towards the equatorial low pressure which is at 0 degree latitude. तो देखा आपने कहां से विंड आ रही, यहीं से गई और यहीं वापस आ गई. Did you see this? Yes? So यहां पे क्या हो रहा है? Air ascends means air moves up. Air descends means air moves vertically down. वही एयर आपका साइकिल को कंप्लीट करके फिर से लो प्रेशर पे आ गया. Is this thing clear? Yes? The most ideal scenario we can assume for such movement is either the month of March or September. क्योंकि in the month of March and September, what is happening is the sun is directly shining on equator. इस पे 0 degree latitude पे the sun is directly shining, and because of that 30 degree north latitude as well as the regions which are located on 30 degree south latitude, they remain slightly cooler. Evaporation is lesser and therefore the winds subside or descend at 30 degree north and 30 degree south latitude. बताइए, डायग्राम क्लियर हुआ आपको? सबको? Is this clear until now? Yes or no? पूछिए, बोलिए. हमेशा. Very good. Because 0 degree latitude receives maximum sun's insolation in 1 year in 2 months, March and September. लेकिन जो हमारे 30 डिग्री नॉर्थ और 30 डिग्री साउथ के रीजन्स हैं, उसमें या तो जून में गर्मी होती है, जून से गर्मी होती है, या फिर दिसंबर में कहां पे होती है, 30 डिग्री साउथ में. वो एक एक बार हीटेड होते हैं. लेकिन अगर हम स्पेसिफिकली मार्च एंड सितंबर का केस लेते हैं तो ऑब्वियसली दिस इज व्हाट वी सी. यस, क्योंकि मार्च और सितंबर पे द सन्स रेज आर डायरेक्टली शाइनिंग ऑन इक्वेटर. इसको बना लीजिए, कंप्लीट करिए डायग्राम को. विकास बोलो. विकास, हाँ बोलो, मैं क्लास में हूं, बोलो ना. क्या हो गया? अच्छा ठीक है, चलो 11:30 आ जाए. Is this diagram clear?
Yes, sir.
बना लिया सबने? Have you made the diagram in your notebooks?
Yes, sir.
So please write down. Air moves in the form of wind. Air moves in the form of wind from high pressure area to low pressure area, from high pressure area to low pressure area, to fill the vacuum, high pressure is the zone where air molecules are found close to the ground, while low pressure is the zone where a vacuum is created due to upward movement of the air molecules. Next paragraph. The equatorial regions are the regions which receive maximum sun's insolation therefore are are for most parts of the year, therefore are for most parts of the year low pressure zones. Most parts of the year are low pressure zones. Full stop. In comparison to the equatorial region, in comparison to the equatorial region, comma, the North Pole and the South Pole located at the North Pole and the South Pole located at 90° north and 90° south latitude and 90° south latitude are the zones of high pressure are the zones of high pressure. High pressure. Since only the indirect rays of the sun since only the indirect rays of the sun reach there, creating cold temperature conditions. Reach there, creating cold temperature conditions. Full stop. The poles and equatorial regions, the poles and equatorial regions, therefore, are called thermally induced pressure belts. Thermally induced pressure belts. See spelling here? Thermally induced pressure belts. Next paragraph. The low pressure zone around equator, the low pressure zone around equator is an area of convergence of winds, is an area of convergence of winds convergence of winds from 30° north and 30° south latitudes, from 30° north and 30° south latitudes 30 degrees south latitude. Full stop. Since the equatorial region receives maximum sun's insolation, since equatorial region receives maximum sun's insolation, comma, the air molecules are heated by the surface, and in the process water gets evaporated, converting into gaseous state, full stop. This process of evaporation of water from the surface, and upward movement of air molecules together, leaves a vacuum on the ground, and air molecules and upward movement of air molecules together leaves a vacuum on the ground in the form of low pressure, full stop. When the air molecules along with water vapor reach upper atmosphere, particularly where temperature becomes sub-zero, sub-zero का मतलब less than 0 degree centigrade, where temperature becomes sub-zero, condensation of water molecules water gaseous molecules कर दो उसको, condensation of water gaseous molecules into liquid water droplets takes place forming clouds, This zone of cloud formation, this zone of cloud formation becomes a high pressure zone in the upper atmosphere, becomes a high pressure zone in the upper atmosphere, from where air again begins to move, from where air again begins to move towards higher latitudes, air again begins to move towards higher latitudes where low pressure is existing in the upper atmosphere, where low pressure is existing in the upper atmosphere. Full stop. The reason REASON, the reason for this low pressure REASON, okay? The reason for this low pressure is that in the lower atmosphere, around 30° north and 30° south latitude, 30° north and 30° south latitude, air molecules exist. Air molecules exist air molecules exist near to the surface, and therefore right above them vacuum exists in the form of low pressure. Right above them vacuum exists in the form of low pressure. Upon reaching the two low pressure zones, upon reaching the two low pressure zones in the upper atmosphere, number two low pressure zones in the upper atmosphere, the air molecules descend down in the absence of significant heating. The air molecules descend down in the absence of significant heating in the absence of significant heating further strengthening the high pressure zone at the surface around 30° north and 30° south latitudes. High pressure zone around
further strengthening
the high pressure zones around 30° north and 30° south. Further strengthening the high pressure zones around 30° north and 30° south latitudes. Full stop. On the surface, comma, finally, the air molecules from both these latitudes, again begin to move towards equatorial belt, where low pressure exists, again begin to move towards equatorial belt where low pressure exists in the form of vacuum, where low pressure exists in the form of vacuum. Where low pressure exists in the form of vacuum. Is this clear until now? Yes? सबको? अब देखिए, वेरी गुड, ये देखो, जहां पे हमारा एयर असेंड हो रहा है ना, यहां पे क्या बनते हैं? क्लाउड्स. और अगर क्लाउड्स बने तो जब क्लाउड्स बिकम सैचुरेटेड विद वाटर मॉलिक्यूल्स, यही पानी नीचे गिरता है इन द फॉर्म ऑफ रेनफॉल. बारिश होती है ना यहां पे. इसलिए इक्वेटोरियल रीजन्स आर नोन फॉर मैक्सिमम रेनफॉल. दे आर नोन फॉर मैक्सिमम रेनफॉल. तो एयर असेंडिंग will condense in the upper atmosphere, form clouds, and these clouds, when they become heavy with water droplets, the water falls down due to gravity in the form of rainfall. लेकिन where the air is descending, बताइए, ये जो 30° नॉर्थ और 30° साउथ का रीजन है, यहां पे रेनफॉल होगा क्या? यहां रेनफॉल होगा? इस डायग्राम को देख के बताइए. Rainfall will be lesser here, right? Why rainfall will be lesser? Because instead of air ascending here, the air is descending. क्या हो रहा है? The air is descending in both the latitudes. Descending air का क्या होता है कि जो upper atmosphere में टेम्परेचर है और जो सरफेस पे टेम्परेचर है वो दोनों अलग अलग हैं, डिफरेंट है. कैसे डिफरेंट है? कि जो अपर एटमॉस्फेयर में टेम्परेचर है इस जोन में, ये जो जोन आप देख रहे हैं जहां पे मैं टिक मार्क कर रहा हूं, ये जो जोन है इसमें टेम्परेचर विल बी लेसर, एंड व्हेन द एयर मॉलिक्यूल्स डिसेंड डाउन द टेम्परेचर ऑफ द एयर मॉलिक्यूल्स विल इंक्रीज. तो ये तो ऑपोजिट हो गया. लेकिन कंडेंसेशन तो कब होता है? कंडेंसेशन ओनली हैपेंस व्हेन द टेम्परेचर रिड्यूसेस and this air and water molecules become clouds. But when temperature, instead of reducing, temperature increases, when the air descends, there is no cloud formation. यहां भी क्लाउड नहीं है और यहां भी क्लाउड नहीं है कि नहीं? There are no clouds here. We're talking about this belt, this belt. There are no clouds. And since there are no clouds, there is no rainfall in this belt. यहां भी रेनफॉल नहीं होगा और यहां भी रेनफॉल नहीं होगा. Are you getting this point? Descending air will never bring about condensation resulting into clouds. Only ascending air will bring about condensation resulting into cloud formation. Did you get this point? सब कोई?
Yes, sir.
इसलिए in comparison to any latitude, and especially in this case we are talking about 30 degree north and 30 degree south latitude, the rainfall is maximum around equator. Yes? So please write down one more paragraph. Ascending air over equatorial regions results into condensation at higher altitudes forming clouds which ultimately bring about rainfall. Full stop. On the other hand, which ultimately bring about rainfall. Full stop. On the हाँ बोलो. Ascending air results into over equatorial regions. Ascending air results into condensation, forming clouds, which ultimately bring rainfall. Full stop. On the other hand, descending air over 30 degree north and 30 degree south latitudes, does not result into condensation, and hence there is no cloud formation, comma, ultimately negligible rainfall. Hence, there is no cloud formation, comma, ultimately negligible rainfall. ठीक है, कल हम कंटिन्यू करेंगे, इसके कुछ और एग्जांपल्स लेंगे. ओके, अभी तक ये सबको क्लियर हुआ? This diagram and whatever we have done previously about low pressure, high pressure and the movement of winds. Is it clear to all of you?
Yes, sir.
Okay, very good. So thank you for tonight and we'll continue tomorrow.
Thank you, sir.
Thank you. Bye-bye.